Section 5 takes Section 4 and adds one thing to it. So if you understood 4, you should be pretty good with 5. Take a look at this equation right here. If that equation is true, then what can we say must be true? One of them has to be 0. Because the only way I can multiply two numbers together and get 0 is if one of those numbers, or both I guess, is 0. And what we see there is called the zero product property. You learned this back in Algebra 1. So I can say that because A times B equals 0, A equals 0, or B equals 0. So what I'm doing is taking this thing right here, whatever it is, that first factor, and making it equal to 0. And then I'm taking the second factor, whatever it is, and I'm making it equal to 0, because in order for two things to multiply to give you 0, one or the other or both have to be 0. That's the whole idea in this section. The zero of a function is wherever a graph crosses the x-axis. We have several names for that. We have roots, solutions, x-intercepts, 0. They're all the same. They're different ways of saying the exact same thing, where the graph crosses the x-axis. When the graph crosses the x-axis, the y-coordinate is 0. So I'm going to add this on here. When the graph crosses the x-axis, the y-coordinate is 0. That is a really crucial thing for our success in this chapter. Because then what's going to happen is your equation y equals some stuff, the y will turn into 0. And then you'll be able to factor and use the zero product property. The zero product property is that idea that we just talked about. The idea that if two things are being multiplied together and they equal 0, then one or the other, or both, must be 0. The zero product property is written out right here, so that would be the third time you've seen it now. And then to solve quadratic equations, get everything on one side. So to solve, to find the solution, to solve, it means to get everything on one side of the equal sign, get 0 on the other side of the equal sign, then factor. You'll wind up with what we were working on yesterday, but then equals 0 on the other side. And this is basically the zero product property right here. We have something, I don't know what it is, but it's something, times something else. I don't know what it is, but it's definitely something else, equals 0, which means that this equals 0 or this equals 0. So then I can split it up. Alright, so solve by factoring is what the directions say. Notice that we have this equal sign here now, so we are working on equations, whereas last time we were just working with expressions. Expressions don't have equal signs, equations do. Expressions say factor, equations say solve. So we have equals 0 sitting here. If we didn't have equals 0, we'd move everything over to one side so that we did have equals 0. You have to have equals 0, otherwise you can't use the zero product property. That's why it's called the zero product property. If you have equals 2, you can't do what we're about to do. It's not called the 2 product property. The property doesn't work anymore unless it's 0, okay? So, first of all, I want to factor this guy. We're good at factoring now, so we know that this is a 1 right here, which means that I can break this into a FOIL type problem immediately, equals 0. I can put my variable in the first position in each one of those binomials. I can look at my signs and decide what kind of signs I'm going to have in between. So with that positive 6 and that negative 5, my two signs must both be negative. Negative 2 and negative 3. Put them down and then check. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So we've factored it correctly. And now what we have here is two things being multiplied together, giving me 0. So that means I can use the zero product property. Since it's multiplication here, and I just have two things being multiplied together, I can split this up and say that this must be equal to 0, or this must be equal to 0, in order for the whole thing to be equal to 0. So I write x minus 2 equals 0, or x minus 3 equals 0. And then we solve for x. X equals 2, x equals 3. So what that's saying is if x is 2, then the equation is equal to 0. If x is 3, then the equation is equal to 0. So we can check that. Take 2 and plug it in. This becomes 4. And then 4 minus 10 is negative 6. Negative 6 plus 6 is 0. Take 3 and plug it in and check it. We get 9 here. We get negative 15 here. Put those together and you get negative 6. Negative 6 plus 6 is 0. Okay? So both of those answers work. Those are the solutions. If I were to graph this equation, I would see a parabola that crosses the x-axis here and here. Let's see. This one looks pretty nasty. What should I do? Get everything on one side or the other. Doesn't matter which side you choose. But you do have to have a positive x squared term. Doesn't matter if the number is 1 or some other number. You want x squared to be positive so that when you factor it, you don't get weird results. So I'm going to do what? I need to add 2x to both sides. And at the same time, I'm going to subtract 2 from both sides. That gives me okay. So I want to solve by factoring, it says. So what do I need to do? GCF, but there isn't one. Because A is not 1, I need to use the box method here. So I'm going to, what? AC equals 60. So I'm looking for two numbers that multiply to give me 60 and add to give me 32. This one probably jumps out at people right away. It's what? 30 and 2. 30, comma, 2. 30 times 2 is 60. 30 plus 2 is 32. So I have my two numbers. Set up the box. Five x squared in the first box. 12 in the last box. 30x in one box, and then 2x in the other box. All right, GCF for each row and column. Top row, just x. Bottom row, make sure you get the biggest factor. 6. 6 times 5 is 30. 6 times 2 is 12. There's no other GCF between those two numbers, so it must be 6. First column, 5x, and second column, just 2. Okay, so last time, once we were done with the box method, we wrote out the factors, and we're going to do that still. 5x plus 2 from the top, and then times x plus 6 from the side. But now it's an equation. Remember, it equals 0, so we're going to write equals 0. We have two factors, equals 0, so we can use the zero product property. Split it up and we get 5x plus 2 equals 0, or x plus 6 equals 0. And then we just solve. The one on the right is easy. We get x equals negative 6 as one answer. And then on the other side, we just solve for x. So that's 5x equals negative 2. So x equals negative 2/5. That's my second answer. Third one, what should we do? Right now? Set it up like FOIL right now? We don't have equals 0, so we need to get that negative 12 out of there. So I'm going to add 12 to both sides, and when I do, I get x squared minus 7x plus 12 equals 0. Can we set this one up like a FOIL problem, or do we have to use the box method here? Yeah, we can go straight to the factors. Two numbers that multiply to give me what? 12, but add to give me negative 7. Both have to be negative, so I have x minus, 3 and 4. It really helps when you think about those signs. Now what? Zero product property. X minus 3 equals 0, or x minus 4 equals 0, so therefore x equals positive 3, x equals positive 4. There's my two answers, and I'm done. And the fourth one, what should we do? Yeah, we got to get equals 0 over here. We have a positive x squared sitting over here, so I want to get this stuff out of there. What do? Subtract 4, add x. The 4x squared sticks around. We get what? Good, negative 13x, and then plus 3 equals 0. Now what? GCF. Is there a GCF here other than 1? No. So now what? AC equals? Okay, so I'm looking for two numbers that multiply to give me what? 12. And add to give me negative 13. Both my numbers have to be negative, negative 12 and negative 1. Check it to make sure. Multiply them together and you do get positive 12. Add them together, you do get negative 13. Now what? Draw your box. Okay, 4x squared, then what? The 3 here, good. Negative 12x, and then negative 1x. All right, now what? GCF for my first row, x. GCF for my second row, negative, because that first box is negative, and then the GCF is 3, negative 3. First column, 4x, and then negative 1. Good. Now what? Good. 4x minus 1 times x minus 3 equals 0. Now what? Set them both equal to 0. Use the zero product property. 4x minus 1 equals 0, or x minus 3 equals 0. And then just solve for x. This one's easy. X equals positive 3. This one becomes 4x equals positive 1. So then x equals 1/4. So you have your two answers here. 3, 1/4. So again, if this was a parabola that I graphed, that parabola would cross the x-axis at positive 1/4 and also at positive 3. You can also solve quadratic equations by graphing. Again, you just need to put all your terms on one side in standard form and then enter it into a graphing calculator. So it's kind of treating it like y equals your function rather than 0 equals your function. Have the calculator do the work. This is mostly useful when an estimate is acceptable, and you'll know when an estimate is acceptable, or when you're using an equation that's really ridiculous numbers. The zeros can be not nice integer values. Those 4 problems that we're just working on, we got nice values as our answers. A lot of times in your quadratic equations, if you're trying to find where the graph crosses the x-axis, you don't get nice numbers. And that's when a graphing calculator is most useful, when a decimal approximation is okay. So we want to solve these two equations by graphing. This one's already set equal to 0 here, so this one's ready to graph. This one is not equal 0 here, not ready to graph. What do I need to do to that first one? Subtract 15. So I get 2x squared plus 7x minus 15 equals 0. So now what we're going to do is graph these on our calculators. So bring up your calculator and then bring up the graph. You can do that just by pressing the calculator button on the calculator twice, the one that looks like a calculator. Just press it twice. So type in that function that we just had. It was 2x squared plus 7x and then minus 15. And then hit enter. And you can see on here that we have what would be a parabola if we zoomed out. If I wanted to, I could grab my x-axis really quick and slide in to zoom it out, and you can see that it's a parabola. Okay? I don't need to do that though. All I'm looking for on these problems is where the graph crosses the x-axis. I'm looking for the solutions. So remember that you can factor to find your solutions, you can graph to find your solutions. And on the graph, it's where the graph crosses the x-axis. So what we want to do is make the calculator come up with these answers for us. So I'm going to press menu. Anytime I want the calculator to do something for me, I press menu, and then probably I'm going to analyze the graph. Now, which one of these do we want? No. 0. Remember that the words for solution are like 0, x-intercept, root, solution. Okay? 0 on the calculator is the same as x-intercept, is the same as solution. So that's the one that we want. So go ahead and click on that one. And then just like with your other stuff that we've been doing with this, we need a lower bound. So go over to the left side of your 0, click, it'll change to upper bound, slide across that first 0 and click out of it. It won't do both zeros for you at the same time. So we have a solution here of -5, 0. Then we need to repeat that. So menu, analyze graph. We want 0 again. And now we're going to get this 0 on the right side. So I need to be on the left side of that right 0. Click, and then slide across. And it will give me that ordered pair. Click out of it. My mouse is in the way, so I move it. And I get 1.5, 0. So my two solutions here, if I were to go ahead and solve that equation, would be x equals -5, and then x equals 1.5, or 3/2 would be my answer. But the calculator will do this for you. So we need to write that down. So let me get rid of this here. Because I did it on the calculator, there's no real work to show. I could factor this thing using the box method. I'd need two numbers that multiply to give me -30, but add to give me +7. Whatever those two numbers are. The answers I got, though, was x equals -5, x equals +1.5, which I know is 3/2. Think you can handle that? Yeah, if you're doing it on a calculator. But if it says solve by factoring, I got to see the factoring. If it says solve by graphing, then you can use a calculator. Okay? Let's do the second one. X squared plus 2x minus 24. So I go back to my calculator. I don't need this function anymore. So what I'm going to do is press tab, and it's going to bring up my function window. And then I'm going to press up, and that's going to bring up the function that I just graphed. And then I'm going to delete all that information and change it to my new function. So I go to x squared plus 2x minus 24. Now notice that even though I deleted that first function, it's still sitting there. What's going to happen here is the calculator is just reassigning that function to what it just did, which means when I press enter, my parabola changes, but it also is still giving me those ordered pairs for my new parabola. So the work is already done. I just had to change the equation. The zeros are already there for me. It's x equals -6 and x equals +4. So I can go back to my graph here, or my page here, and I can write down my answer. X equals -6, x equals 4. So that's the advantage to using these calculators, and then thinking about what you're about to do. Go back and delete the equation and change it to this new one, and then all of the additional work that you have to do to get those zeros is already done for you. It automatically adapts. We can use that idea to do a problem like this. We have a frog jumping competition apparently, and the graph shows the function modeling the height of one frog's jump, where x is the distance in feet from the jump start. So the jump starts right here, and the jump ends right here apparently. And then the equation that they give you is sitting right here. How far did the frog jump is the question. Well, what that is asking me is to find this coordinate right here. If this is 0, then this is how far the frog jumped. We'll get an ordered pair, and the ordered pair will be something, comma, 0. So if I have the equation, which I do, then I can find the zeros of this equation. And if I do that, then I'll get this ordered pair, and that will instantly tell me how far the frog jumped. So let's go ahead and do that. Go back to the calculator. And now I want to change that equation to my new equation, which is negative 0.029 x squared plus 0.59 x. I hit enter. This frog's path is not on my graph, so I got to change my window. So I'm going to try to change my axis here by zooming out. Okay, this guy's in the way, so I'm going to move it. And my ordered pair didn't show up, so I guess I just got to find a new, what? 0. So I go to Menu, Analyze Graph, New 0. Lower bound is going to be on the left side of that 0 where the frog lands. Click, slide across, click out of it, and it gives me my answer of 20.3, comma 0. 20.3 what? Miles? Feet? This frog jumps 20.3 feet? That's pretty amazing. Is it really feet?
Yeah.
Distance in feet. So this frog jumps 20.3 feet. That's pretty far. Now, how high did the frog jump? How high the frog jumped? Maximum and minimum, yeah. The height of the frog is right here, the highest part of the frog. So what do I need to do? Meaning, find what part of this graph? Yeah, we're looking for the vertex. So, go back to the calculator. And this time we're going to analyze what? The maximum. So I slide across to the left side of that vertex, click, slide across to past the vertex, and click, and it gives me this ordered pair here, which I can't see. So I'm going to click and hold to get this thing to move. 10.2, comma 3 is what I got. So I'm going to write down that ordered pair. We got 10.2, comma 3 as an ordered pair. Now we need to talk about how high the frog jumped. How high did the frog jump?
3 feet, because your x was your
Right, they're both feet, actually.
Well, yeah.
This 10.2 is the horizontal distance here, the x-coordinate. So he was 10.2 feet into his flight when he reached his maximum height, which was 3 feet. So you got to really kind of think about some of these when you do them. What is a reasonable domain and range for such a frog jumping action? What's a reasonable domain here? All real numbers? That would include like -5. The frog can jump -5 feet.
All real.
Domain is greater than or equal to 0. Theoretically, the frog could jump as far as possible, right? But it cannot jump a negative distance. So the domain is going to be x values that are greater than or equal to 0. The frog could jump nowhere, or the frog could be on the moon and jump 45 miles. The range will be all the y values that are getting graphed. If the frog's jumping, he's not going to go through the floor, right? So he can jump as high as he wants. Maybe he's on an asteroid in space and there's not much gravity there at all, and therefore he winds up jumping 22 miles. So the range is y values greater than or equal to 0 as well. Okay? In reality, the frog's not going to jump an infinite height. The frog's not going to jump an infinite distance. But this is what we're dealing with here.